Go.
Hi Tanya, how's it going?
Good.
Good. Okay, so I know you're like my chill friend who loves to paint, so I just thought I'd share some information about motor control because I think it's really interesting, and then I'll maybe listen to what you have to say about painting later in another day. So basically, motor control is the way that we understand how we move, why we move, what muscles are involved, how our brain can send signals to those muscles to actually complete a movement. And so the primary focus of motor control is the behavioral elements. So what we can do as an individual to produce that movement is all about motor control. So if we want to see what goes into a specific movement, such as painting, because I know that you really love that, there's several steps that we have to understand. So you love to paint, that's why I picked this as an example. So if you were to paint a beautiful scenery, but you only had a small canvas to paint it on, there is much different motor skills that you have to use to paint on that small canvas as opposed to if you had like this giant canvas. So like if you had a bigger canvas, your motor control would be a lot more gross motor, meaning that you have bigger muscles working in bigger motions, but with our small canvas, we're gonna have more fine motor skills of your hand and wrist control and all that. So during this process, your brain is already kind of thinking about what you're gonna paint and how you're gonna do it, and it's also doing that creativity piece of painting, and your brain is like sending those pathways or like signals to each other, and then once you decide to paint, then those signals go from your brain to your muscles, and then you complete the action. And there's this whole stages of steps that your brain goes through to do that, but that's essentially what it is a signal from your brain to your muscles. So then even before your hand touches the brush, neural signals are being sent throughout your brain in preparation. When you grab the paintbrush and dip it into the paint, you are now in the stage of activation and execution. So those neural signals have reached your hand already. And then this basically means that what was being sent is an afferent signal from your brain to your muscles to perform the movement. So when you're painting, do you ever change the position of your hand, how hard you press, how like swoopy you could do it?
Always.
Do you change those things?
Mm-hmm.
Okay, so that's good. So that means that you're taking in feedback from what you want to paint and how you want to paint it, and you're changing your motions. So why I brought that up is because that means that painting for you is more of a closed loop event, so which means that you can take in feedback and change how you're doing it with each movement. And then lastly, I'd say as a painter, you need a lot of fine precision movements with those fine motor skills as opposed to gross motor skills, which we kind of talked about before. But do you have any questions?
No.
Okay.
That was a great explanation.
Thank you.
Mm-hmm.
Hi, so today I will be teaching you about the concept of motor control. But to start, I want you to stand up and we're going to jump up and down 10 times. 2, 3, 4, 5, 6, 7,
This is fun.
9, 10. So do you know why or how you were jumping?
Yeah, I mean, I just like that.
Well, actually, there's more to it. You're using your brain. In your body, we have thousands of neurons. They send information to your brain, which helps you to produce movement, such as when you were jumping. These neurons are like a gift. So if you were to receive a gift from a friend, you would get excited, right?
Yeah.
So wouldn't you want to kind of give back to that friend?
Mm-hmm.
That would be a form of sensory and motor neurons. You would be receiving information, which would be your sensory neurons, but you would be giving back, which would be using your motor neurons. Yeah. And so I have a couple more examples for you. So what would you say your favorite breakfast food is?
Toaster strudel.
Okay, so if you were to have a toaster strudel, you would put it in a toaster. So when you put the toaster strudel in the toaster, it would be considered an open mechanism. And an open loop mechanism is where it stops. It has a stop, but it goes on because it's set to a specific point. So when you put it in, you don't want it to burn, right?
Mm-mm.
So you put it in for a certain amount of time, and once you put it in for that a certain amount of time, it will stop and it will pop up.
Yeah.
And then it will be done. So that would be open looped. There's no feedback being put in.
Mm-hmm.
Whereas, let's imagine you're hula hooping. So Or you are holding the hula hoop in your two hands and you move it from side to side. This is a closed loop mechanism because it's continuously moving. It's never stopping, right? So that would be a closed loop mechanism.
Oh.
Do you have any questions?
No, this is really confusing though.
I know. Hi Tanya, so what are you going to be teaching me today?
Hi Lexi. So today I'll be talking to you about motor behavior and the series of steps or information you need to go about executing a movement. So something you need to understand is the model of perception, cognition, and action. And basically this model consists of these three concepts, but within these concepts we also have a series of steps, and that includes sensing, the perceiving, interpreting, conceptualization, strategy, activation, and execution. So to prepare for a movement, we first have to use your sensory receptors. So these sensory receptors are detecting your external and internal stimuli. So for the external, we're talking about anything that's outside of the body, your environment, and then for the internal, it's just like either your nervousness or if you're nauseous about a certain movement. And then also another thing you have to understand is proprioception, which helps us understand where your body is in space and then in relation to the movement that you're doing. So the next step for perceiving is the what it means, and that is the process where you're taking in this information to plan for the actual movement. And then the next part is the interpreting. So this is the step where your brain is making sense of the information you're receiving prior to the movement. And then for this part, for the interpreting, you're using a high level of cognitive processing, since you have to plan for either problem solving or decision making abilities. And then the next step is for conceptualization. So this is a step where you actually plan prior to the movement. So the sequence for either a gross motor or fine motor movement, or the coordination. So how smoothly the movement will be executed. And then for the last part, which is the last couple of parts, is a strategy and plan. Your brain is identifying the necessary physiological, biomechanical, or the psychological characteristics needed to plan for this movement. And then once your brain has that planned, organized in the brain, then it's gonna send it to the primary cortex, where then it's carried out to the effectors. And the effectors it consists of your muscles, ligaments, or joints that actually carry out the movement. And that's all. That was kind of like